Okay, so we're going to look through some summations, and we're going to talk about summation and factorial. First off, factorial, which is an exclamation point. It simply means to multiply any integer terms lower than that between 1 and the number. So for instance, if I write 3 factorial, then I'm talking about 3 times 2 times 1, which is equal to 6. So 3 factorial is equal to 6. If I'm talking 5 factorial, that's 5 times 4 times 3 factorial, which is 20 times 6, which is 120. Okay. Notice I simply replaced 3 factorial with that. That is a very useful trick for doing this, because it can help you and save you some time and do some it can simplify some things for you so that you don't have to work as hard. So with that taken care of, let's look at number 1. They want you to find the first 4 terms. So we have A1 is 2 to the 1 over 1 minus 1 factorial, which is going to equal 2 factorial over 0 factorial. Just a heads up, 0 factorial is always assumed to be 1 by definition, so that is going to be 2 times 1 over 1, which is just 2. If we want a sub 2, then we want 2 to the second over 2 minus 1 factorial, which is 4 over 1 factorial, which is 4. A sub 3 is 2 to the third over 3 minus 1 factorial, which is 8 over 2 times 1, which is 4 over 1, which is 4 again. And a sub 4 is going to equal 2 to the fourth over 4 minus 1 factorial, which is 16 divided by 3 times 2 times 1, which is 8 over 3, so that is 8 thirds. Okay, so that is the first 4 terms of this problem. Okay, so that one is taken care of. So notice there's not really a distinct pattern here. This is times 2. From here to here, this is the same thing, times 1. This goes to 1. This adds 1/3 to it, so there's no distinct pattern being done. So it's not geometric or arithmetic. Or it's not really even a pattern for a sequence for that matter. So next one, let's evaluate a sub a is 10 factorial over 2 factorial 8 factorial. Well, rather than use a calculator, we can write this as 10 times 9 times 8 factorial on top over 2 factorial 8 factorial. Well, 8 factorials will cancel. This is 90 divided by 2 times 1, which is 45. And that is very quick to get done with. For part B, we have n plus 1 factorial over n factorial. Well, n plus 1 factorial is n plus 1 times the next one down, so n plus 1 minus 1 times n plus 1 minus 2, and so on and so forth. Well, isn't this thing, and then, or not plus, times 1. Eventually you'll get to the last term, which is 1, times 2 times 1. Well, isn't this just n times n minus 1 times dot 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 times 1? Well, n plus 1 times that? Well, isn't this n factorial just simply this thing? Yeah, it is. So this is n plus 1 times n factorial over n factorial, which is simply just n plus 1. Okay, so that's the trick to that. So for these ones, we can separate. You can separate if there's an addition. You cannot separate if there's multiplication or division. But with this being said, notice there are boundaries. So we're looking at part A. So we have a sum. Oops, that's an ugly summation sign. Sum as I equals 1 to 6, I squared plus 1. So all you have to do to complete this, guys, is you're going to plug in each value from 1 to 6 and then add it all together. This means add it together. This is the lower bound. This is where you start. This is where you end. So what is this? This is 1 squared plus 1. That's the first term. Plus, that's because this is summation. The second term is going to be 2 squared plus 1. That looks weird. I'm not going to. I don't need that. I don't want it to look like a fraction. Plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared plus 1. Okay, and I'm putting parentheses just to keep track of everything. So the 1, 2, 3, 4, 5, and 6. 6 terms because this is 6. And we go from 1 to 6. Okay, so 1 squared plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared 9 plus 1 is 10. 4 squared 16 plus 1 17. 25 plus 1 26. 36 plus 1 37. If we add all this together, 37, 26, 17, 10, 5, 2, we get a total of 97. So this is 97. The sum of this is 97. Okay, that one's done. It's pretty straightforward. It's not particularly difficult. For the next one, we have the following. We have the sum. It's ugly. The sum k equals 4 to 7, negative 2 to the k minus 5. Alright, so one thing we can do, we can separate these because there's a subtraction going on here. We could have done this with the last problem, but we can separate these into two different problems. So what we can do is we can write this as, I just want to show you this. This is useful if you have to do pre-calculus or something. I keep making these ugly. There we go. K is equal to 4, 7, negative 2 to the k, then plus negative 5 times the sum. That one's ugly. From 7, k is equal to 4 to 7 of 1. So what I've done, I factored this negative 5 out of this. Okay, and so we're just going to add the numbers from 4 to 7 one at a time, 4 times, or 3 times. And then we're going to also do this. So to do this, we're going to do negative 2 to the 4th plus negative 2 to the 5th, negative 2 to the 6th, plus negative 2 to the 7th. And then at the same time, we're going to add the following. We're going to add 1 plus 1 plus 1 plus 1. There are 4 different ones. We have from 4 to 7. So we're going to add that 4 times, but we're going to multiply that by negative 5. So we're just going to do plus negative 5 times that. Okay, and so negative 2 to the 4th is negative 2 times negative 2. That's 4 times negative 2 times negative 2. 4, that's 16. Plus negative 32. Plus 64. Plus negative 128. And then plus 4 times negative 5 is negative 20. Okay, and so if we add all this together, we have 16 plus 64 minus 32 minus 128, and then minus 20. Negative 100 is your answer for this one. And so as you guys can see, there's different ways to do this. Let's do the last one. We have the sum from 5 and I is equal to 1 of 3. Well, notice there is no I in this equation. So we're simply just being asked to add from 1 to, we're going to add 3, 5, 4, well, let's just count. This is the first one. This is 1. plus 3 again, that's 2. 3 again, that's 3. 3 again, that's 4. 3 again, that's 5, and that's the last one. So we started at 1, we ended at 5. This is a total of 15. So we can also factor the 3 out. We'll do that again. I equals 1 and 1, just like I did in the previous problem. And then we have 3 times 1 plus 1 plus 1 plus 1 plus 1, which gives us 15 as well. And so you can see there are little tricks and things you can do with these summations to get what you need. It's especially useful if you're doing calculus and things like that. Thank you guys.